Assalamu alaikum. We know the position of an object can be determined with the help of a coordinate system or a frame of reference. In this video, we will discuss about the position vector. A position vector is nothing but a vector which gives the position of an object at a given time in or with respect to the frame of reference or a coordinate system. So, a vector which gives the position of an object at a given time. With respect to the frame of reference or coordinate system. Okay, this way called as the position vector, which is usually represented by letter R vector. Okay, now with the help of a simple example, I'll explain this. So, suppose I have a point P. Okay, to know its position, see this point, it is not possible to get the location or position of this point as such, without using a coordinate system. Only I can able to say that there is a point on the board, but where it is located, it is too difficult to say without taking the reference. Now I have to say that it is located at a 2 meter from the left wall, or 1 meter from the right wall, and 1.5 meter from the floor, and 3 meters from the roof. Only by taking the reference of something, one can able to give the exact location of some object. Isn't it? That is why we use a reference frame or a coordinate system. So let me draw that one here. Here, this is a Cartesian coordinate system which has got 3 axes: x-axis, y-axis, and z-axis. Now one can easily give the position of this point. Okay. Now here, if I draw a line which connects this point from the origin, then it can be referred as a position vector, letter R. Clear? Now I drop a line here. I drop a line from point P, which goes parallel to z-axis. Got it? Then a line is drawn perpendicular to this line, which intersects at the x-axis. Okay, then I draw a line which is just parallel to x-axis. Now this is how one can get the exact position of point P with respect to coordinate system. This line represents x-axis, this represents y, and this represents z-axis. Okay, these 3 lines give the exact position of point P with respect to the coordinate system. So the position of point P is given with respect to these 3 axes. Okay, got it? Now the position vector, that is R, can be resolved into its components. It has got three components. One along x-axis, another along y axis, and third one is along a z axis. So it is written as r vector is equal to rx I cap, because it acts along a x axis, then ry j cap as it acts along a y axis, and rz k cap as it acts along a z axis. Here, what is this I cap, j cap and k cap? So long ago I have told you about this. A vector which acts along a unit vector which acts along the x axis is nothing but I cap. A vector which acts along the y axis is nothing but j cap, and a vector which acts along z axis is nothing but k cap. Okay, this is what we have written here. These unit vectors actually provide a direction to a given quantity. Clear? That's all about it. Now we will solve one problem relevant to position vector. Now here I have taken 4 points on this coordinate system. Here this represents the x-axis and this represents the y-axis. If it is so, then the line extending in the opposite direction represents minus x-axis, and this represents the minus the y-axis. Okay, here we have got 4 points P, Q, R and S. I am going to get the position vector of all these 4 points. For that, I have to draw a line from the origin. This is the origin. Okay, where all the coordinate, where all the axes meet. Okay, so line drawn from the origin towards that point with the arrow mark is referred as position vector. So these are all 4 position vectors of 4 different points. I will start with this. Now I name this line with arrow mark as RP vector. RP vector. This is the position vector representing the position of the point of P. Okay, here the 1, 2, 3 point is at the third point along the x-axis. So its position is 3, and the unit vector along x-axis is nothing but I cap. Okay, the next I'll find out the position vector at point Q, or the position of vector point Q. RQ is vector. Now here we have dropped 2 lines from the tip of vector Q. Okay, this name is RQ vector, this position vector, which gives the position of Q. Okay, it intersects at this point, just 1, 2, 3, 4, 5. Okay, 5. So here it is along x-axis, so I take it as 5I cap. Then a line is dropped here from this point so that it can intersect here along y-axis. Here 1, 2, 3, 4 point. So it's along the plus y-axis, so plus 4 J cap. Okay, this is the position of point of Q. Now I'll get the position of R, which is represented by this position vector R vector. Okay, I'll see what does it say, R vector. Here it is at the second point from the origin, 1 is 2, and along the minus x axis, so minus n is used here, 2 as it is along the x axis, so I cap. Then fourth one R S vector, which gives the position of a point S. Okay, now the the perpendiculars are dropped from the head of vector S. One goes towards x-axis, another goes along minus y-axis. Here, this line intersect at this point, which is at 3. Okay, 1, 2, 3. So, plus 3 is written as it is along x-axis. So, I cap. Then position of S with respect to minus y-axis. Yes, 1, 2, 3, 4, 5, 6. It is a distance of 6 points from origin. So, first I use the minus sign because it is along minus x-axis, minus y-axis. I'm sorry, minus 6. So, the unit vector along y-axis is nothing but j cap. So, these are all the position vectors of different points that we see here. Now, as it is given in 2 coordinate system, we have got only x-axis and y-axis. If it is placed in a 3 coordinate system, then along with these two things, z-axis will also get included. Okay. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put a question in the comment section. Thanks for watching.